No, I don't know. Yep. Okay, so we're finishing up 8.2 and 8.3, and then tomorrow I'm going to teach 8.1, and then you can take your test on Wednesday. Okay, so the only thing that we haven't covered in rational functions is slant asymptote and point of discontinuity. So those are the two problems we're going to work today. One's going to have a slant asymptote, and one's going to have a point of discontinuity. All right, so here's the first problem. F of x is equal to x squared plus 3x minus 4 over x minus 2. So go do all your stuff, okay? We're going to draw a graph. When you draw the graph, leave more room at the top than you do at the bottom, okay? Kind of cheat a little bit. It's going to take some room at the top. And then we're going to find all these things, the domain and the range, the vertical asymptote, the horizontal asymptote, the slant asymptote, the point of discontinuity, the x-intercept, the y-intercept, and we are going to make a little t-chart. Okay, everybody got it? All right, what's the first thing we're supposed to do? Factor, factor, factor. Very good. So, what does this top part factor into? Okay, x plus 4 and x minus 1. Bottom part, he doesn't factor. Okay? All right, so let's just start at the top and let's go down. Domain. How do you find the domain? What am I supposed to do? Zeros of the denominator. So I take the denominator. Yep. Set it equal to 0. And so that would be 2. So what is my domain going to be? So what's my domain going to be? An interval notation. Negative infinity of 2, exclusive, and union what? 2, exclusive to positive infinity. Very good. Everything except for 2, okay? We always come back and do the range. Are y'all with me? Y'all remembering this stuff? All right. Vertical asymptote. X equals 2. It's the zeros of the denominator, but it is a line, so you have to say x is equal to 2. And then we usually go over here and we draw it. Okay? Now, when I say horizontal asymptotes, what are you supposed to think? Degrees. What's the degree of the top? 2. What's the degree of the bottom? 1. Oh, this thing's bigger on the top than it is on the bottom. It is top heavy, bad, so what? No. It's none, okay? It doesn't have 1. Okay? He doesn't have 1. So that was supposed to be an upside down triangle, but I don't know what happened to my pen. He like went on a mission or something. See? Look at him. I don't know why he's doing that, but anyway. Something over there was bothering me. All right. Now, if it doesn't have a horizontal asymptote, does that mean that it has a slant asymptote? Very good. No, but it means that it could. Now, when does it? Only if the degree on top is one more. Very good. If the degree on top is one more than the degree on bottom, then it has a slant asymptote. Does it have a slant asymptote? Okay, so, and it is y is equal to, and y'all look, it's the answer to this problem right here. It's what do you get when you divide this top by this bottom. That's it. That is the equation you're looking for. Okay? Now, there's two ways that we could do this one. We could do long division, or this one, because this is just that x plus or minus something, we could use synthetic division. I'm going to do long division because, guys, if this were a cubic on the top and this were an x squared on the bottom, could I use synthetic division? Mm-mm. You can only use synthetic division when it's x plus or minus something. Okay? So I'm going to do long division just to kind of make you remember. All right? So x minus 2 divided into x squared plus 3x minus 4. Now, the other class told me that I evidently had forgotten to write something on your cheat sheet. So let's make sure we have it on there. So on slant asymptote, it says only if there is no horizontal asymptote and the degree on top is one more than the degree on bottom. And y is equal to the quotient when you divide the numerator by the denominator. Does it say anything else? No. Okay, I forgot evidently to tell them that, so they didn't have that. So when I asked them, what do you do with your remainder, they hadn't the idea. So I'll ask you, what do you do with your remainder? You just ignore it, okay? You don't even think about it. All right, so let's see if we remember long division. What do you multiply x by to get x squared? X. So remember how we kept them all lined up so they looked nice and neat? All right, now what do I do? Yeah, now you multiply. X times x is what? And then what's x times negative 2? Negative 2x. Now what do we do? You've got to change all the signs. And the reason is because you are subtracting. But guys, listen to me. If you just put a subtraction sign here, then the only thing that you're going to subtract is that first term, and then you're going to miss this term. Okay? So we don't do it that way. We say we're going to change all our signs and add. So he becomes a negative. What does he become? So what's x squared? Pardon me. And negative x squared. All right, and those first two should always cancel out. All right, what's 3x and 2x? Now what do I do? Yeah, you just start all over again. What do you multiply x by to get 5x? So what do I put here? Plus 5. Very good. And then you multiply. What's 5 times x? And what's 5 times negative 2? And then what do I do? Change your signs. Good deal. So it becomes a negative. This one becomes a positive. My 5x's cancel out. What's negative 4 and positive 10? That's my remainder. What do I do? Just ignore it, okay? So what is my slant asymptote? Y is equal to what? X plus 5. Okay? So let's go and graph it. Now, obviously, people, if it's a slant asymptote, it's going to be slanted, right? Okay? All right. So what is his y-intercept? 5. So I go up. 1, 2, 3, 4, 5. What's his slope? 1. So I'm going to go up 1 and over 1, up 1 and over 1. I'm also going to go down and to the left. Okay? I'm also going to use some common sense and know that his x-intercept has got to be negative 5. Because negative 5 and positive 5 make 0. All right. Now, these are a little bit more difficult to draw, but here is my slant asymptote. And they'll be glad that I'm not painting the dots on the highway. It depends on what that is right there. So, yeah, you know what? One time when Mom and I were going to a store to go shopping, and it was out of town. It was back in Arkansas, and we drove over there, and there's a little bridge, and it's one of those little pretty bridges that has the pretty ornate concrete edges that you know make arches and arch up and everything. Well, an armadillo had gotten killed on the side of the road, and in between, I guess, the time when he died, and they painted the stripes on the highway, they just painted right over the armadillo. And so there he was on the side, and he just had a big white stripe over him, and then going on off the road. I was like, that is so lazy. That's just wrong. You did? Well, I saw it on the highway in Arkansas. Actually, it was on the edge, but it was kind of funny. We laughed. Okay, so everybody okay? All right, so let me show you once I get these two asymptotes, this is what my brain is saying to myself, okay? It's saying, okay, I'm either going to have a curve, one of those crescent things, but it's going to look more like a parabola. It's not, but it's going to look kind of like that. I'm either going to have one down here opening down and up here opening up, or I'm going to have a big, wide, kind of fish-looking thing on this side and this side. Those are pretty much my choices, okay? 99.9% of the time, that you're going to look at either up and down or side and side, okay? All right, so let's just finish finding our stuff. Do I have a point of discontinuity?
No.
Why?
Because none of it reduces.
Very good. None of the factors reduce. All right, what about an x-intercept? How do I find an x-intercept? The zeros of what? The numerator. So I've got x plus 4 times x minus 1, and I set it equal to 0. What's this one?
X equals -4.
Or?
X is equal to +1.
So he has two x-intercepts. One's at -4 and one's at 1. Do I want to put parentheses around those? No, because then that'd look like the point -4, 1, and that doesn't have nothing to do with our graph. You see what I'm saying? All right, so don't be crazy. So here's 1, and 1, 2, 3, 4, and here's -4.
Yeah, that actually falls on the asymptote.
Do what?
It falls on the asymptote.
No, it doesn't. The asymptote's right here at -5.
Maybe. Go up one now.
Well, I know, but I haven't drawn him yet. He's not going to fall on the asymptote, I can tell you that.
No, the point -4, 1.
Oh, I see what you're saying. I'm sorry, Spencer. Yes, you're right. But some people wouldn't care. They would still. And especially if they draw this point, if they put parentheses around it, somebody's going to copy it off their paper, and then they're going to plot it, right? So, all right, how do I find the y-intercept? All right, so I got 0 squared plus 3 times 0 minus 4. That's the top. What's that going to be? All right, on the bottom I got 0 minus 2. What's that? What is -4 over -2? So my y-intercept is +2. Okay, now, right now, do I know what my curve, don't draw it yet, do I know what my curve looks like, where they are? Yeah, y'all look. See these points right here? He's telling you, hey, this one's probably going to come like this, which means the other one's probably going to be up here. Okay, but I'm not going to draw it because I want to tell you this. When your curves go down like this and up like this, I want you to find 2 points. I want you to find what of this curve? The maximum, and what of this curve? Very good. And I want you to graph them, and I want you to put them in your T-chart and label them. Okay? All right, you're going to see why in a minute. So, now y'all, I'm just going to go do it on my calculator, okay? I mean, we're not going to, like, pull out the slide rule here and go crazy. We're just going to go to our little calculator. I'm going to say x squared plus 3x minus 4 divided by x minus 2, right? Okay, I'm going to go zoom 6. All right, so look at what I'm looking at on my calculator. 1/3 of the kids are going to miss this graph. Why? That's right. They're not going to see that top part, and they were not paying attention, okay, or not using their brain either today in class or when you take your test. But does this thing have a top part? He most likely does. All right, so I'm going to just go, I'm going to do it this way. I'm going to go to my windows and change my windows. You can zoom out. If you need help with that, you need to say something. I'm going to go -20 to +20 on a scale of 2, and -20 to +20 on a scale of 2. So now I'm going to graph it. All right. Now, we want to find this point's what? Maximum. Y'all, it's somewhere in this flat part. All right. I don't know that it looks like that's 0.2. I know because we graphed it. But it looks like it might be that, but I'm not sure if it is or not. That's why I'm going to make the calculator find it. So I'm going to go second and calculate. What am I looking for? A maximum. So I'm going to choose. I'm going to choose number 5. No, I'm not. Sorry. Number 4. I'm going to choose number 4. Okay? And then I want the left bound, so I'm going to go to the left. I just want to get to the left of that flat part. I'll press enter. And then I'm going to go to the right. And I just want to get off of that flat part. Okay? Oh, no, whoa, 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 whoa. Dadgum. I just went a little crazy. Don't get carried away now. All right, there's my right band. I don't want to guess. So there it is. Was it at 0.2? Y'all, it's not at 0.2. It's at -0.45 and 2.1. Okay? So I'm going to go over here. On my T-chart, I'm going to put -0.45 and 2.1. And what am I going to write beside it? What? Maximum. Okay? So almost -0.5 and up to 2.1, just a little above that one. Now, I can draw this, right? I know what he looks like. Uh-oh, my pen quit. There you go. What? There's nothing confusing about that. He's just following those little asymptotes. He's approaching them. Okay? Now we go back to our little calculator. And now I'm going to find this minimum right here. So I go second and calculate. I'm going to choose number 3, a minimum. Now, obviously, I already showed you how to get over to that other part if you didn't know, because I went crazy pressing the right arrow button. Okay, so there he is. So I'm going to back off just a little bit. There's my left bound. There's my right bound. I don't want to guess. So it is 4.45 and 11.9. I don't care how many places. Don't write 11 or don't write 12 because that makes it look like it's exactly, and it's not. Okay? So I'm going to write 4.45 and 11.9. 4.45 and 11.9. And what am I going to write by it? Men. All right, so 1, 2, 3, 4.45, and there's 10, 11.9, so almost to 12. Okay, so what do you think about this over here? What do I need to do? Do you think 1 point's good enough to draw the curve? I don't think so either. I think we need to find some other points. So what do you want to pick? Okay, how about 2 and 5? I like 2 and 5. I mean, not 2, 3 and 5, right? Because that's at 2. So I'm going to pick 3 and 5. Now, watch what I'm going to do, people. Where am I going to get these points? Yeah, I already got it in my calculator, people. Why not just use it? So second and table. There's 3 is 14. And 5 is 12. 3 is 14. and 5 is 12. Yes, you will. 3 is 14, so he's up here somewhere. And 5 is 12, so he's that point right there. So here's my curve. All right. What's the only thing we lack? Okay.
From, wait. Okay, so this is going to be
Negative infinity to what?
0.1.
Okay, now listen, stop right here because I'm going to tell you this is just my personal preference, okay? Different teachers will do it different ways. There's not a, I mean, there's a wrong way to do it. There is that, okay? But what I choose to do, and if someone else chose to do it differently, that's just a personal preference thing. Here's what I choose to do and what I want you to do. Is this exactly 2.1? We rounded it off, right? When I round it off, I don't include it because it's not exact. Do you see what I'm saying? Okay? I don't like to include it because when I include it, it makes me think that it was exactly 2.1. If it were exactly 2.1, then I would write 2.1 and I would include it. Okay? But it's not. So I'm going to say negative infinity to 2.1 exclusive, and then union what? 11.9, and that, again, that was not exact. We rounded that off. It was 11.889, all right? Blah, 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 blah. I kept on going all the way to positive infinity. Okay, anybody got a question? If it's exactly, if when you find this maximum point, if this maximum point had said negative 0.445987 whatever, and like it did 2.10 whatever it was, we rounded it off, right? So don't include it. If you have to round it off, don't include it. Okay? If it said negative 0.445 blah 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 blah, and then it said 2, then I would have included the 2. Okay, now let me ask you this question. This is a problem and this is all wonderful. Alright? What if, I'm pretending, right? What if that curve had actually been right here and right here? Would we have needed to find a domain, a max and a min? No. What would have been my range? Very good. I just wanted you to understand that. Okay? You wouldn't have needed to find a min and a max because it didn't have one. All right? And it went from negative infinity to positive infinity. All right. Everybody okay? Okay. That's exactly right. You can look at the graph and tell. Okay. So now let's go to the next one. All right. My pen got stuck. All right. Here's the next problem. The next problem is f of x is equal to, on the top, x squared minus 5x minus 6, and on the bottom, x squared minus 1. Draw you a graph. This time on your graph, you can kind of spread your points out. It's going to be okay. I try to warn you when it's kind of crazy like that one was a little bit. Was it raining when y'all came in here? Yeah, it's been windy for the last couple of days. Just a small chance, not a huge chance. So, domain, range, vertical asymptote, horizontal asymptote, slant asymptote, point of discontinuity. You might see that one here right now. That's intercept, y-intercept, and t-chart.
Now, can you factor and then do the point?
You should always factor. You should always factor. It should be the very first thing that you do. Because look, can I reduce these x squares? Please tell me you would never do that. Okay? If you did that, I just want to go 0.
We're doing a Franklin D. Roosevelt chart. Factor, domain range chart.
Okay.
SDR chart.
All right. What about the VA-HA-SA-PD-XY?
Well, he was most of the tapes we have of him were recorded on VHS.
Oh, there you go, VHS. Because they only had VHS back there in Franklin.
They were converted to VHS from the audio tape.
Okay, so here we go. You don't have to memorize this, guys. You'll be okay. Yes, it's awesome. My wedding is on VHS. The kids were like the other day, yeah, Katie said, Mom, I want to videotape my wedding. I said, oh, okay, ours is videotape. She goes, what?
Mom was like, I got the VHS of my dad and your dad and mom's wedding, and I was like, okay. And she goes, yeah, but we can't watch it.
That's right, because we don't have a VHS anymore.
We have one.
What's even better
Do y'all?
We have.
Yeah, watch old movies and stuff. We don't have one. Okay.
What's even better, looking if you filmed it on beta.
No, remember they said, I don't know, y'all don't remember this, but back when they first came out, everybody said, oh, VHSs weren't going to make it and betas were going to make it. And so some people got a beta recorder, player, whatever you call those things, right? And then they ended up having to get rid of it because it didn't.
They should have kept betas so much better than VA.
Yeah, and that's what they said, and then it didn't work. All right, so let's factor, okay? So, what does the top factor into? Very good. X minus 6 and x plus 1. What about the bottom?
Plus 1.
Okay, x plus 1, x minus 1. All right, now, what do you see? Oh, the x plus 1's cancel out. Don't scribble them out, guys. Just put a line through them. Okay? Now, since those cancels out, what do I know that I have? Okay, and y'all listen to me. Just like everything else that we found, it's going to be what x is if you set this equal to 0. So what is the point of discontinuity? -1. Don't write x equals -1 because that's going to look like an asymptote or something. All right? So just write -1. Thank you.
Yes, please explain.
Why is it -1? Because when you set x plus 1 equals 0, what do you solve x for? X to be -1.
So, does that affect our domain?
Okay. Now listen to me. Y'all, a point of discontinuity is a hole in your graph. Okay? It's just a hole in the graph. Now, let me tell you why it's a hole in the graph. Because -1, what's -1 squared? 1. What's 1 minus 1? Does my function exist at where x is -1? No, it doesn't. What's it going to say in the t-chart? Error. Is it an asymptote? No, it's a hole in your graph. Do I have to exclude it from my domain?
Yes.
Because it makes a 0 in the denominator. You see what I'm saying? Does your domain thing say zeros of the denominator except where there's a hole in your graph? No, it says zeros of the denominator. Okay? So, you're going to say x minus 1 times x plus 1. So what equals 0? So what's this one? +1. What's this one? -1. So what is my domain?
-1.
Perfect.
Union.
-1 to 1.
Union
1 then.
Perfect. Okay? Anything that creates a 0 in the denominator has to be excluded from your domain. Your function does not exist there. It's undefined. Okay? Some of them might be vertical asymptotes. Some of them might be holes in your graph. It's only a hole in your graph if it cancels, if it'll reduce. Okay? So, vertical asymptote. You can't, it's not a number, people. It's a line. X is equal to 1. Is it X is equal to negative 1? No, that is no longer a vertical asymptote. It's a what? A point of discontinuity. That's a hole in my graph. Okay, so let me show you how to do these. Vertical asymptotes, you know how to do that. Draw your little dotted line. Okay, now I'm going to tell you, you don't have to do anything for the point of discontinuity, but I'm going to tell you this. If you don't do something, you're going to forget about it when you go to graph it, and then you're going to get points taken off your graph because you don't have it on there. So this is what I do, all right? Wherever it is, it's where X is negative 1. I just make some dots. Now listen to me. Did I make a dotted line? No. And I'm going to come back and I'm going to erase those dots. Okay? I'm just making those dots. You're going to see why, but I'm making those dots because you know what those dots say? Those dots say, hey, wait, Billy Gay, if you're graphing that thing, you better stop here. Something's happening. I got a hole in my graph, and you got to draw a hole in your graph, an open circle, because that thing does not exist right there. Okay? Horizontal asymptote. What are you supposed to think? What's the degree of the top?
2.
What's the degree of the bottom?
2.
Oh, that's equal representation. Okay? So what's the leading coefficient of the top? What's the leading coefficient of the bottom? What's my horizontal asymptote? Y equals 1. Go over here and draw it. Okay, so let's see what we know so far. All right? Do you know I have 2 asymptotes, one vertical and one horizontal. So do I know that my, it's like I get up and then it starts working. All right, do I know that this, I'm going to have a crescent on this side of the vertical and a crescent on this side of the vertical. Everybody agree? It's either up here or down here. Don't know where it is. This one's either up here or down here. Everybody with me so far? Okay, so slant asymptote, none. How do I find an x-intercept? Zeros of what? Okay, now listen to me. If this is a hole in the graph, can it be an x-intercept? People, it can't be an x-intercept. It's a hole in the graph. The graph does not exist there. So don't do that. X minus 6 equals 0, so it's at 6. So I have an x-intercept at 6. 1, 2, 3, 4, 5, dadgum. 6. Okay? Do I know where this part of my crescent is? Yeah, people, it better be down here. Okay? All right, how do I find a y-intercept? Okay, so 0 squared minus 5 times 0 minus 6 over 0 squared minus 1. Now, what's the top going to give you? Sorry. When you do that, your pen gets stuck sometimes. 0 squared minus 1. All right, so it's negative 6 over negative 1, right? What is it? 6. So my y-intercept is 1, 2, 3, 4, 5. Dadgummit. I just didn't go big enough. That's right. All right. So here we go. Now I'm going to say 1 point's not good enough to do my curve. Okay, so I'm going to pick another point. So yeah, I'd pick 2 over here. And what would I pick over here? Negative 1?
No.
No, people, it's a hole in the graph. Okay? All right.
Negative 2.
Negative 2? All right, I'm okay with negative 2.
I like negative 7.
You can pick negative 7. All right. So I'm going to do this. I'm going to go ahead and put it in my calculator. Y is equal to x squared. What was it? Plus 5x? Minus 6 over oh, stop it. He wouldn't go and then he took off. X squared minus 1. To what? Yeah, sure. You want to do 3? Okay, so I'm going to go second in table. And Abby wants to go with Negative 3. So let's see, what was the other one we went with? 2? No. Oh, 3?
3 so 2 because it's actually on track.
Do what now?
What? Two negative four.
Okay, I did something wrong. Never mind.
Okay, so at 2 it's negative 4. Okay. Boy, you've been being good all day long, Mr. Inner Right Pad. 2, it's negative 4. And what was the other one we picked? Negative 2?
8 or
So,
2 and C.
okay. I'm going to say 2.7. All right. So at negative 2, it's 2.7. And at 2, it's what? Negative 4? Is that right?
Mm-hmm.
So 2, it's negative 4. Okay, so here's what this one looks like. It looks like he's kind of pulled off of that center point just a little bit. All right. I'm tired of playing this game, so I'm going up here. Okay, so there's this one. All right. Now this one over here. Now don't draw this one. Just hang on for a second, okay? At negative 2, it's 2.7, which is not quite 3. Okay, so here's what's happening. He's coming down here, right? Okay, he's going down to this point. Y'all listen to me. As soon as he gets, come on, right here, I got a hole in my graph right there. And that's what he looks like. Now do you see what the dots are for? The dots are just a reminder to me when I draw across that. Now what am I going to do with the dots? I'm going to go back and erase them.
So, like, is it wrong if we left the dots?
I don't care if you leave the dots. Here's what happened to my PreAP kids. The kids that had me last year, they did what they made the dots. The kids that didn't have me, what did they make?
Asymptote.
That's exactly what they made. And so I couldn't tell if they didn't know that it was an asymptote, or if they just drew, instead of just drawing little bitty light dots, if they drew a dotted line. I just couldn't tell, so I counted off. So, I don't really know. Now, here's my question, okay? Let's do the range.
So is 2
Tell me what
points
the
enough?
range is.
Negative infinity.
The 1. Now, I'm going to tell you this, that upper math, maybe as you go on, they're going to make you find what that y is and exclude that from your domain, because it is excluded from my domain, okay? And it's not that big a deal to find, but we're not going to, all right?
No, what Y?
The
The
Y.
y that goes to this hole in your graph,
There's a hole in mine.
okay? All right, and then this is from 1 to positive infinity.
So we don't include it in it.
Not
No,
right
we're
now.
not going to. All right, anybody got a question? Okay, so here's my point. Now, everybody stop and look. When I look at this graph, okay, if I accidentally made an asymptote here and here, because that's the mistake that kids do. Please tell me that you can look at this graph and go, whoa, wait, there's not an asymptote at negative 1. I must have messed up somewhere. Does everybody understand that?
Yes.
Okay, look at that graph. Can you see a hole in that graph at negative 1?
Not right, kind of.
Y'all listen to me. You cannot look at that graph and see a hole. Not one soul in this classroom can. Okay? Can I see it on my T-chart?
Yes.
I see it on my T-chart. Okay? What? You want to see it? No, it doesn't look funky right there.
You look funky.
Watch this. Here's where it looks like. Where was it? At negative 1?
How do you find that Y if it's error out the calculator?
You leave those factors out and plug it in. Now watch this. Watch it. Are you ready? Are you ready?
Not really.
Let me show you what a hole in the graph looks like.
Whoa.
There it is. It's a hole in the graph right there. Yep. I went from negative 1.1 to negative 0.9. Very, very small. No, we used to do it that way. And then
sometimes it'll work and sometimes it didn't, and so then we figured out what to do. All right. Ta-da! So tomorrow we're going to cover one other thing, and then we will be ready for our test.
I feel like it. Did you stop recording?
Oh, no, I didn't.
Hello, the screen's off, but you can still hear me. This is the math class that never is. This is the math class that never is. It's the math class that never is. I mean,